Hello students, I'm Dr. Z. I miss our visits, but your teachers have told me that you have begun studying the weather. So I'm here to talk a little bit about weather and maybe doing a few experiments that you might be able to do at home. Scientists have been studying the weather for a long, long time, and we all benefit from that because it's very easy for us now to know what the weather's going to be like 1 day, 2 days, even 10 days out from now. You can go to your television or your computers and it's very easy to get a 10-day forecast. But we would never have been able to do that if it hadn't been for the scientists who over many, many years have been studying and observing the weather. Remember, we've talked about how observations are so important in science. And today, we can observe the weather of the Earth from satellites way out into space. And that really has helped us to understand more about the weather. So what is weather? What causes the weather to change? It can change so drastically. One day it's nice out, the next day we got thunderstorms, high winds and so forth. Well, the big answer is it's very complicated, okay? Scientists have been studying weather for a long time, and it is complicated. But let's try to make it easy. And let's just talk about two major causes of weather and weather changes. And those two things are the sun and air pressure. You all know about the sun. That big ball out there, extremely hot, 93 million miles away from us, yet the energy from that hot ball travels all the way to the Earth, and it heats the Earth. It heats our oceans, our lakes. It heats the air. The sun, if we didn't have the sun, we just wouldn't have any life at all. So the sun is very important, and the fact that it heats up the earth and the air and the water around us. The other very important thing is air pressure. And to try to understand what air pressure is, I'm going to tell you what a very smart scientist about 400 years ago was observing the weather around him and finally realized that we all live at the bottom of a sea of air. No one had really realized that before. We live at the bottom of a sea of air. The Earth is completely surrounded by air, and you look up, that air goes up 7 miles before it starts hitting space. Air and the sea of air is very important to our understanding of the weather. Air doesn't weigh much, right? If you fill up a balloon with air, it's very light. But if you look straight up, 7 miles up, the weight of that air becomes very significant. It acts on all of us, and that's what's called air pressure, okay? So the weight of that air is called air pressure. And that air pressure can change from place to place, and that often is due to the sun and the heating. So I think we talked about the fact that air, which is a gas, when it gets warm from the air, it expands, right? And when it expands, it tends to rise, okay? Colder air, which is up high above us, the air above us, way above us, is a lot colder. That air tends to sink. So this change in air pressure all the time, all over the Earth, is actually the reason that wind blows. Wind is air in motion, right? And this change in air pressure from place to place causes cold air to come in and replace the warmer air. So we say the colder air, which is high pressure, comes in and flows into the area of low pressure, which is the warmer air. So this is why we have winds blowing, the sun heating the air, heating the earth, various places differently, causing the winds to move. And that's really what basically causes our weather. So let's talk about doing an experiment. Sometimes a big change in this air pressure can cause storms. And for example, if you've got what they call low air pressure, which is usually warm air rising up, and it meets very cold air pressure up in the sky, the meeting of those two areas of air can actually cause the air to start rotating. And that rotation can become very serious and can cause what we know as a tornado, right? You've heard about tornadoes. Luckily, we don't get a lot of tornadoes here where we live, but in other areas of our country, it becomes a big problem. And they can be very, very destructive, do a lot of damage. So tornadoes, again, are really caused by changes in air pressure, warm air rising, meeting cold air in the sky, causing a rotation of the air, and that air can start going faster and faster and faster, and eventually form what they call a column of air or a funnel of air, and it will actually reach the ground. And that funnel will travel along the ground and cause a lot of damage. It can destroy homes and can actually kill people, as you well know. Since it's air circulating and air is invisible to us, it's only because that column of air is churning up a lot of dirt that you'll see this funnel of air look brown, gray, dark, and that's because of all the dirt. Okay, so let's do a quick experiment that kind of visualizes what one of these tornadoes look like. Some of you may have done one of these before. It's called a tornado in a bottle. All I did was I took 2 soda bottles. You either drink what's in here or throw it out. And get yourself one of these connectors. You can get these on Amazon. You can see there's a hole in the middle, and you can screw the bottle, one on the top and one on the bottom, real tight. If you can't find one of these, you can take the 2 bottles and you can glue them together. Take some really good glue, or you can just take some real good tape and tape them together. And you don't have to use bottles this big. You can use smaller ones and you'll get the same effect. So what I've done is I filled the bottom bottle with water, and I put a little coloring, food coloring in there just to make it easier to see. And what you do is you turn it upside down and you rotate this one a little bit, and then you just wait for a little, keep rotating, and eventually you're going to start forming this funnel, which is what a tornado looks like. We could imagine that my green water here is actually air, and that air is circulating and causing this column or funnel, and that funnel reaches the ground and it moves along the ground. And the air is going at a very high speed, and that's what causes so much damage. It can wreck houses and wreck schools. It can do a lot of damage. There's one interesting thing. Let's do it one more time. one interesting thing that I want you to observe, when you get your tornado rotating there, just got to work on it a little bit. It will eventually start. If you look from the top down, you'll notice that the water is rotating in what we call a counterclockwise way. That means it's going opposite, spinning opposite the way a clock goes. Now, where we live here in what's called the northern hemisphere of the world, the upper part of the world, most tornadoes go counterclockwise. If we lived in Australia, which is in the southern hemisphere of our world, and you looked at a tornado, it would be going clockwise. And that has to do with the gravity and the way the earth is spinning. It's kind of interesting, okay? So you can make one of these at home. It's a lot of fun to play with and observe, and maybe you can think of other things to do with it. I'm going to let you do that. But before I leave you, I've got one more experiment I wanted to share with you. Here I have a plain old ordinary water bottle that I bought at the supermarket. And inside the water bottle, I have what is known as a medicine dropper, okay? You know, medicine droppers are used to drop medicine or liquids into something. This is a kind of a rubber top, and you squeeze it, and you can bring water up into the glass tube. And you see, I made some blue markings on that tube, on the medicine dropper, just to make it easier to see. So what you do is you fill your bottle all the way to the top with water, and then you squeeze some water into your tube, into your medicine dropper, just about halfway. And you can buy these things, I think, at the drugstore or even the supermarket, or maybe your parents have one of these around somewhere. So you fill the water about halfway up the tube, and then you just let it float there in the bottle of water. Take your cap and close it. And okay, this is where the magic starts. We've got our medicine dropper floating, and I'm going to pull an invisible thread, and I'm going to pull that medicine dropper down to the bottom, and then I'm going to let it go back up. Pretty neat, huh? Let's see that again. Here's my invisible magic thread. I'm pulling it through so the medicine dropper falls to the bottom. And now I'm letting it go up to the top. Okay. What do you suppose is going on here? Well, I know I didn't fool many of you. There's no invisible thread here. There's nothing. And I didn't share with you one little trick. When I want to get that medicine dropper to fall to the bottom of the bottle, all I do is squeeze a little bit. Isn't that neat? You can hardly see me squeeze it, but I am. And then when I let it go, it goes to the top. Well, what's going on here? Well, I'm not going to tell you exactly how it works. Maybe you can do a little research with your friends or your parents. This all has to do with, why does something float in water, but why does something sink in water? And here's another hint. It has to do with air pressure. Okay, we talked about air pressure today. And the pressure, if you do this experiment and you look at your medicine dropper at the top there, and when you squeeze the bottle, I want you to observe what's happening in the medicine dropper, okay? And then when you let it go, look at it again. And maybe the difference of what you see in that medicine dropper from the top to the bottom will give you a really good hint about how this works. And by the way, there is a name for this experiment. It's called a Cartesian diver. A Cartesian diver. Pretty neat, huh? Okay, guys, it was good being with you, and I hope maybe we can do this again soon. Have a good day. Take care.